Long division versus synthetic division. Because one of the things we're going to do in the process of sometimes finding that oblique asymptote, we're going to do a long division. A long division is called that polynomials. It could be a long process. And it's a situation that I would do if I was given a division and I couldn't do a linear binomial. Like for B, I would probably still use synthetic division to carry through that division. For A, 2x squared minus 5, it really doesn't factor into some nice stuff for me to be trying to do two different synthetic divisions. And even with that, a synthetic division where I have a remainder becomes even more complicated for me to do. So anytime I'm dividing by something that's not a linear binomial with a leading coefficient of 1, which is what I don't have in A. I'm dividing by I'm dividing by a quadratic binomial in the bottom there. I'm going to use long division. And here's the procedure. Long division is needed because that's not a linear binomial. So what I do, and what you're noticing here is I'm putting what was on the bottom to the left of my normal long division symbol. Notice I did not have an x term originally. I am replacing it with a 0x. So anything that's missing from the normal pattern, going from highest power down to lowest power, I need to have a representative of that power of x, but I'm going to put a coefficient of 0 in front of it because it really isn't there. And I do the same thing inside because I have the 4x cubed plus 10x squared plus 0x. I don't have an x term, plus 9. And how I carry through long division is like this. Well, I have three terms on the outside, so I'm going to be moving three terms at a time as I move through this. But I do focus my attention on the leading coefficients each time. So I'm looking at the 2 here, the 2x squared, I'm looking at the 4x cubed. And I'm going to ask myself a question. 2x squared times what gives me 4x cubed? And whatever that answer is going to be, and in this case it's going to be 2x, that's what I'm going to put on top here. So 2x times 2x squared would give me the 4x cubed. Now what I do is I multiply the entire three terms I have on the outside by that 2x. So 2x times 2x squared becomes the 4x cubed. 2x times 0x becomes 0x squared. 2x times minus 5 becomes a minus 10x. And that's how I get those three terms down there. Now, if you remember your long division of numbers, the next thing in the process becomes subtraction. I'm going to carry through a subtraction. When I carry through this subtraction, I'm going to have some sign changes here. I mean, this is going to become a minus 0x squared. Doesn't really matter. Subtracting 0, adding 0, still nothing happens. What's more important here, I had a minus 10x here. It now becomes a plus 10x because I'm subtracting a negative. When I carry this through, the first term should cancel. That's why I always make sure that I'm multiplying by something that makes the exact same first term as what I had. 10x squared minus 0x squared becomes 10x squared. 0x plus 10x becomes plus 10x. And then what you notice what I did next is I brought the very next term down. Just like we would normally bring the next number down in my long division. So now my leading coefficient is now negative 10x squared down there. So I ask the same kind of thing. 2x squared times what gives me 10x squared? Well, 2x squared times 5, or more notably a positive 5, would make that become 10x squared. So that's what I'm going to put here, a positive 5, a plus 5. 5 times 0x so 5 times 2x squared gives me the 10x squared. 5 times 0x gives me 0x. 5 times negative 5 gives me a negative 25. Again, I'm going to carry through a subtraction. So I'm going to make sure to change the symbols around accordingly. Again, the first terms are going to cancel. They should. That's how you set it up. 10x minus 0x is 10x. 9 plus 25 is 34. I have no more terms to bring down. The degree down here is smaller than the degree that's up here. Therefore, that's all my remainder. So I have a couple options for answers. I would say that's 2x plus 5 plus the with the remainder of 10x plus 34. Or I go back to what I did with fractions and say, well, it's going to be 2x plus 5 plus my remainder over my original divisor, which is the 2x squared minus 5. So this would be the final solution for something like this written in like a completely quotient form.